Hello everyone. For our first review assignment on break, we're going to talk about functions. So the first one says a company that manufactures radio first pays a startup cost and then spends a certain amount to manufacture each radio. If the cost of manufacturing R radios is given by the function C of R equals 5.25R plus 125, then the 5.25 best represents what? Well, everything here is being related back to cost. Now, this is our slope piece, which means we're going to look for keywords like per or each, something along the lines of that. So it's definitely not the startup cost. That's always our y-intercept. The average number of radios manufactured. Well, they're not talking about that. That's R, right? This piece right here is R. That talks about how many radios are manufactured. So it's either the profit earned from one radio, which I guess per, each, or one, they also go together, or the amount spent to manufacture each radio. Well, again, since everything here is talking about cost, that's going to be choice C. There's no mention of profit in this question. Everything is related to cost. The Jameson family kept a log of the distance they traveled during a trip, as represented in the graph below. During which time interval was their average speed the greatest? So average speed is our y2 minus y1 over x2 minus x1 formula. And again, sometimes you can be tricked here by the graph, so you're going to want to go piece by piece. So if we do the first hour to the second hour, that's 110 minus 40 over 2 minus 1, which is 70 over 1. For the second to the fourth hour, that's 180 minus 110 over 4 minus 2, which is 70 over 2. So that's definitely not greater than 70 over 1. 6 to 8. Now this looks the steepest, but again, we're going over a 2-hour interval there. So 350 minus 230 over 8 minus 6 is 120 over 2, which is really, and I'll write down here below, that's really 60 over 1. So close. And again, so although it looks the steepest, it's not, based on the fact that it's over a 2-hour span. And then the last one is from the 8th hour to the 10th hour. And I think we can tell pretty easily that this is not the one that is it. It gives us 40 over 2, which is 20 over 1. So that one's out. So their speed is the greatest from the first to the second hour. And again, sometimes you can be tricked by the graph if you don't actually sit down and do the equation. In the third one, which point could be used to find f of 2? So remember, when they say f of 2, they mean what is y when x is equal to 2. So if we look, here, right here is where x is equal to 2. It's along this vertical line here. Well, what point does that go through? That goes through point A. So not asking what is the value of f of 2 here. They just want to know which point can be used to find f of 2, and that's the point that's on the x-axis at 2. Let f be a function such that f of x equals 2x minus 4 is defined by the domain. So remember, domain is your inputs. So if we want to find the range, that means we're going to plug in a 2, see what we get, and then we'll plug in 6 and see what we get. So if we plug in a 2, right, f of 2 equals 2 times 2 minus 4. Well, 2 times 2 is 4, minus 4 is 0. And then f of 6 is 2 times 6 minus 4. 2 times 6 is 12, minus 4 is 8. So what's our range? If our domain is 2 to 6, our range here goes from 0, less than or equal to y, less than or equal to 8. So if you plug in any of the numbers between 2 and 6, you'll end up with an answer somewhere between 0 and 8. Which domain would be most appropriate set to use for a function that predicts the number of household online devices in terms of the number of people in the household? So look what we're talking about here. Everything is online devices, people, and we should know we can't have half a person or device, right? We can't have half a person or device, and we can't have negative. So if we can't have any negatives, and we can't have any decimals or fractions or anything like that, we are left with the whole numbers. The integers are close, but they include the negatives, and the irrationals and the rationals include all of our decimals and fractions. So the only one that is positive with no decimals, no fractions, just whole numbers is going to be choice B. If f of x equals 2 times 3 to the x in parentheses plus 1, what's the value of f of 2? So remember, this means plug in 2 for x. So f of 2 is 2 times 3 to the second, close parentheses, plus 1. Follow your order of operations, which says exponents first. 3 squared is 9. Then it's multiplication. 2 times 9 is 18. Then it's addition. 18 plus 1 is 19. So for this one, when we plug in a 2, we should get an answer of 19. Which table could represent a function? Remember, if x repeats, not a function. So usually when they ask these questions, they try to sneak in 3 answer choices where x is repeating. So if we look at the first one here, I see an x of 2 and an x of 2, so we know that one's out. If I go across to choice C, I see an x of 2 and an x of 2, so that one's out. In B, I see 1, 2, 3, 4. Okay, that one looks pretty good. And then in choice D, I see an x of 3 and an x of 3. So the only one that has all different x values is going to be choice B. Which relation is not a function? So if we look here at our table, negative 10, negative 6, negative 2, 1, 5. All x's are different. Therefore, we're good. Choice B is a linear equation, right? If we subtract 3x, we get 2y equals negative 3x plus 4. And then if we divided everything by 2, we'd get negative 3 over 2x plus 2. So if we wanted to like put this in our calculator or pretend to graph it, that would be this line right there, which we know would pass the vertical line test. So that one is a function. Same thing in choice C. As I draw my vertical lines, it passes the vertical line test. So it obviously leaves D as the answer, and here's the problem. The input 2 has multiple outputs. So when an input has multiple outputs, that's kind of like saying that we have an x value that repeats. So if you listed these out, you'd have like 1 comma A, 2 comma A, 2 comma B, and 3 comma C. And then you'd have those x values that repeated, therefore not a function. Which situation could be modeled by a linear function? Remember, that is adding or subtracting. The population of bacteria triples. Triples is dead giveaway exponential. The value of a cell phone depreciates at a rate of 3.5%. Percents are exponential. An amusement park allows 50 people to enter every 30 minutes. So this seems consistent. It seems like we are adding 50 people each 30 minutes. So hold on to that one. And then a baseball tournament eliminates half of the teams. So half of the teams means you are really dividing by 2 or multiplying by 1/2. Anytime you are multiplying, you are exponential. So the only one that is definitely linear is going to be that amusement park because it's going up by 50 people every 30 minutes. What is the range of the function f of x equals absolute value x plus 3, close absolute value, minus 5? So I'm going to sketch a graph on the side over here. So if you need in your calculator, by the way, it's second and then 0. And you want to take that first one that says ABS, all right? And before you do that, you want to go into y equals set your setup and it plugs your absolute value into the correct place. When you do that, you get an absolute value graph that looks kind of like this, all right? Now, when we want to find the range, that's our y values. And remember, the range is from your smallest y to your biggest y. So the smallest y is down here at this point, and the coordinates of that point are -3, -5. So our smallest y would be -5, and it actually hits that spot, so it's going to get a bracket. And then we have arrows pointing up forever, so that means our biggest y is going to be infinity, and infinity never gets a bracket. So our answer here for 10 is A, because our lowest or smallest y value is -5 with a bracket, and our biggest y value is our infinity. The function f has a domain of 1, 3, 5, 7 and a range of 2, 4, 6. Could f be represented? Now remember, it's a function, so x is not allowed to repeat. 1, 2, 3, 4, 5, 6, 7, 2. All of our x values are different, so to justify your answer, so first off, we need to answer the question. Could f be represented by this? Yes. And then you want to state the definition of a function. Each input has at most one output. So you want to make sure whenever you are told to explain or justify why something is a function, what you want to do is you want to write that definition that each input has at most one output. Now, if you're working in the other direction where you're showing why it's not, then you want to show that there's an input that has more than one. But for this question, each input has at most one output because the 1, 3, 5, and 7 were all different inputs. And then for the last one, if g of x equals -4x squared minus 3x plus 2, determine g of -2. So again, this is really all about our ability to plug in and follow order of operations. So -4 times -2 squared minus 3 times -2 plus 2. So order of operations tells us we have to do our exponent first. 4 times -2 squared is a positive 4 minus 3 times -2 plus 2. Now we can do our couple sets of multiplication. So -4 times 4 is -16. -3 times -2 is positive 6. And then plus 2. And then we can add all of our pieces together here. -16 plus 6 is -10. Plus 2 is -8. So we get a final answer of g of -2 equals -8. So remember, for a question like that, just be careful that you are following your order of operations.